Greetings and welcome. This is our second look at parabolas. We were writing equations of parabolas last night, page 659 on our homework. And here is a parabola in general form, problem 21. Let me rewrite it just for convenience. 2x squared minus 12y minus 16x plus 20 equals 0. So looking at this, I want to point out that notice my x term is the only squared term, right? I don't have a y squared term. So therefore, this must be oriented in which direction? Vertical. So that means it must be of the form x minus h squared equals 4p times y minus k, right? So that's what I'm shooting for. And so looking at this, I think what I'll do is I'll gather all of the x's on the left and then the y and the constant on the right. So that's what I'm going to do. Subtract 20, subtract 20. So let's group all of our stuff together. 2x squared minus 12y equals, I'll throw the equal sign here, 12y minus 20. Now, I'm going to have to complete the square over here. In order to do that, I have to get rid of the leading coefficient of 2. So I'm going to take not the greatest common factor, but just the leading coefficient. Why did I write 12y over there, guys? That's not right. What should that have been? 16x. At least 2 does happen to still be the thing that I have to factor out of it. There we go. So I will have 2 times x squared minus 8x blank equals 12y minus 20 blank, right? So we'll complete the square here on this part. So find my new c term, negative 8 divided by 2, and square it. Negative 4 squared is 16. So add 16. And adding 16 in the world of parentheses was really adding 32 in the world of the problem. So I have to add 32 to the other side as well. So now I can fast factor this. So this is 2 times what all squared? Well, that would be an x and a minus 4. And over here I'll have 12y, negative 20 plus 32 is positive 12 by the looks of it. And let's see, I'm almost there. One of the things I want to point out is that notice that in the parentheses for the y, the leading coefficient is 1. So similar to what I just did earlier on the left-hand side, I'm going to have to factor out whatever my leading coefficient is on the right-hand side. So I'm going to factor out a 12. So I'll get 12 times y plus 1, right, equals 2x minus 4 all squared. And I'm almost there. I just got to get rid of this 2. And the way I do that is divide everybody by 2. And I will get x minus 4 all squared equals 6 times y plus 1. Right? So here's standard form finally. And looking at this, let's gather our information so I can graph it. I know that this is vertically oriented. I know that the vertex is at 4 comma negative 1, right? The opposite of that number, opposite of that number. I can find the value of p. So if 4p is equal to 6, right? Because that leading part right there is 4p. I could then divide both sides by 4, and I'd get p is equal to 3/2, or 1.5. Because p is positive, that tells me that this opens in the positive direction. So that is up in the case of vertical, right? I can now find the foci, focus, because there's only one, sorry. So that's going to be 4 comma negative 1 plus 3/2, right? Add p to the y coordinate because of vertical, right? So that's how I'm choosing that. Let's see. So the focus would be 4 comma negative 1 plus 1.5 is either 1/2, or I could write that as 4 comma 1.5. One of the rare occasions we get to write decimals in my class. The axis of symmetry, well, this is vertical, so the axis of symmetry goes with it. It's going to be y equals the y coordinate. And the directrix is going to be perpendicular to that, so it's x equals a number, and it will be the x coordinate of the vertex minus the value of p, right? So 4 minus 3/2, so it would be x equals, well, 4 minus 1.5 is going to be 2.5, or this could have, I could have found a common denominator that would have been 8/2 minus 3/2, x equals 5/2, right? Whichever one of those you might like. And I want to point out once again that the axis of symmetry and the directrix is not a number, it's an equation of a line, right? So don't tell me 2.5, tell me x equals 2.5, because those are very different things. So let's actually graph this. Well, before I find my coordinate plane, 4, -1 opens up. So I kind of like figure out where my quadrant has to be just looking at this information. All right, so 4, -1 opens up. And let's see, so it'll be over 4, down 1, opens up. So I'll just kind of center it there. I know it opens up, so something like that should be sufficient. And now let's plot some points. So over 4, down 1, there's my vertex. My value of p is 3/2 or 1.5. So I'll go up 1.5. So there's my focus. I'll go down 1.5, and here's my directrix. And let's see, a couple other points on this. Well, I use my little squares method. That's not an official name or anything. But the distance between the directrix and my vertex, I think, is 3. If I'm not mistaken, right? 1, 2, yeah, 3. So I'm going to go also 3 units over here, right? So that way I've got equidistant here, which is the definition of the parabola, right? It's a set of all points that are equidistant from a fixed point, the focus, and a fixed line, the directrix. So 3 over there, and then also 3 over here. So kind of perpendicular both sides. And then draw kind of my rough little parabola friend. Close enough. Oh, and of course, I'll throw in the axis of symmetry just for fun, just because I like the colors. So, so there we go. That's how you could translate from general form to standardo, and then get all your information and graph it. So, let's take a look at problem 30, which I currently I only have one strategy of approach for this problem that I can think of, to be honest. And it's probably one that you won't like, but you kind of technically know how to do. I'm going to actually think of writing this in general form. Oh, wow, I'm so glad they gave me this hint, because I would have had to guess twice. I would have gotten 2 answers if I had to do it the other way. Oh, that would not have been fun. So it says it has a vertical axis. So that means the x term is going to be the squared term, and general form is x squared plus dx plus ey plus f equals 0. And guys, unfortunately, I'm going to have to plug in each of these points, x and y, into general form 3 times. I'll get a system of 3 equations and 3 unknowns, just like we did with equations of circles. I do want to point out that 3 points wasn't enough to define the parabola. I had to have this one extra piece of information as well, to kind of be certain that, and also have been told that it was a parabola, I guess. So let's plug in what we can here. So I'll have 1 squared plus d times 1 plus e times -7 plus f equals 0. I'll just go through and do the first step for each of these. Then I'll plug in 5, -3. So 5 squared plus d times -3 plus e times, nope, don't want to mess up this early. D times 5, because I'm plugging in x, plus e times -3 plus f equals 0. And lastly, let's see, hopefully you guys on YouTube could have fast forwarded through this part and just saw that like I was still writing this stuff down. Plus d times 7 plus e times -4 plus f equals 0. So notice, behold, I have 3 equations and 3 unknowns, d, e, and f. So that's something I can solve. We know what we're doing there. So let's actually simplify these a little bit. And I'll even bring my constant over to the right-hand side. So for the first equation, I'll have d minus 7e plus f equals, and if I subtract 1 squared from both sides, I'll get that equal to 1. Right? Here I'll have, yep, thank you, man. Whew. Good save right there. It would have been a lot of work for a wrong answer. And we would have been hunting for the mistake. Let's see, plus, let's see, 5d minus, 3e plus f, and I'll subtract 5 squared, so that's negative 25. And then lastly, I'll have 7d minus 4e plus f equals, and subtract 7 squared from both sides to get negative 49. So here's my system. I'll even label these a, nope, yeah, sure I will. Because I conveniently haven't used the variable names a, b, or c, just d, e, and f. How wonderful. What wonderful weather we're having. So let's solve this. What's your guys' preference? What do you want me to do today? Yeah, sure. Let's do elimination. Looking at the D's for elimination method, between 1, 5, and 7, I'd have to find 35 as my kind of common coefficient, least common coefficient. Between 7, 3, and 4, oh man, those are all relatively prime to one another. That means I'd have to multiply those. So 7 times 12, 70, 84, I think. Yuck. And hey, those F's right there are looking pretty good. So I'll choose the common coefficient of f. So let's see. Let's it doesn't really matter which one I pick, but let's just multiply -1 times c just for funsies. So I'll get negative 7d plus 4e minus f equals positive 49, right? Just changing the signs of that guy right there. And I only need one of these equations to be the opposite of the other two, so I'll use C as my kind of benchmark, and then I'll find the new revised equations, so to speak. Well, yeah, I guess technically, by adding a to -1c, or a minus 1c, and then I'll do b minus 1c. All right, so those are the two things, and that should theoretically eliminate this f and this f for us, right? So let's do a and -1c, a plus this, right? So 1d plus a -7d is -6d, -7e and 4e is -3e. The f's cancel out like my evil plan had figured out, planned in advance. 49 and -1 is positive 48, right? Let's do some b and -1c. So 5d and -7d is -2d. 3e and 4e is -3e, sorry, and positive 4e will be positive e equals, and what's this, 49 and -25, what's that be, 24? Because if this was 50 minus 25, that would have been 25, and it's one less than that, so I believe it's 24. Okay, so now I've got a system of 2 equations and 2 unknowns. Looking at these guys, I'm just gonna do some substitution. So I'm just gonna subs it from here on out. Subs. So I'll add 2d to both sides to my equation right there. And I'll have e equals 2d plus 24. And what do I do with this guy? In which? Yeah, it's got to be the one that I didn't originally solve for. Excellent, excellent. -6d minus 3 times, and instead of e, I'm putting this whole thing in there, 2d plus 24 equals 48. So let's simplify this and solve. Negative 60. Okay. I thought the d's were going to cancel out. That would have scared me. Would have meant no solution, which I guess is a possibility. It's just like, nope, no parabola passes through those 3 points. You've got a problem. Let's see, negative 60 plus 12, 72 equals 48. Combine my like terms here and add 72 to both sides. No, 27, 72. And I'll get negative 12d equals, let's see, a 120. Oh, this looks like this is going to be a nice convenient point. Divide by negative 12. And I'll get d equals negative 10. Ta-da! So I'm done my problem, right? That's what the original problem wanted us to do. Tell it what d was. No, there, no. I'm looking for 2 other things, and then I still have to write this in standard form. So what should I do with this d here? Actually, oh, right here, this one's even better, because that'll have this only has 2 variables in it, one of them being the one that I found. So that'll be helpful. So I'll get equals 2 times negative 10 plus 24. That's a quick simplification right there. Equals negative 20 plus 24. And I'm going to keep rolling with my lame joke. Here we go. Equals 4. There we go. That was awesome. And let's see. Let's do one more substitution here. I'm running out of cool colors here. I guess I'll use blue again. So I'm going to take this and this. Right? So I've got a D and an E, and where should I plug those? Yeah, one of my early ones that also have an F in it. It looks like A is probably the one with the smallest numbers. Right? So I'm going to plug them in there. So 1D, negative 7E plus F. So I'll have 1D, so that's negative 10, minus 7E plus F equals negative 1. Let's see, did I get those coefficients right? Is my short-term memory working? 1 minus 7, 1, negative 1. I got it. So let's simplify this. So this is negative 10 minus 28 plus F equals negative 1. Combine some like terms there. And I get negative 38 plus F equals negative 1. Add 38 to both sides. 37. So I just found D, E, and F for general form of a parabola, the vertical kind. So let's plug those all in to general form. All right, so I guess I might as well label what I'm doing. Plug into general form. Right? So let's do that. So I will have x squared. D was negative 10, so that's minus 10x. E was 4, so plus 4y. F was 37. Plus 37 equals 0. And now I've got general form of a parabola, and this parabola is the specific parabola that happens to pass through those 3 points and is also vertically oriented. So let's bring the x's together, the y's together, that sort of thing. And the constant to the other side. So I'll get x squared minus 10x blank equals negative 4y minus 37 blank. Wow, this has been one long problem, but that's okay. I don't have a leading coefficient for the x, so I don't have to worry about factoring it out or nothing. I can jump right into completing the square. Negative 10 over 2 all squared negative 5 squared. I hope we have become awesome at completing the square in the past week or two here. Adding 25 right here is really adding 25, so let's also add 25 over here. Man, I'm literally running out of space on this page. So this is x minus 5 all squared equals negative 4y minus, what's that going to be, 12? I think. And now I've got to factor out this negative 4 from those two terms. So I'm going to take a negative 4 out. So I'll have x minus 5 squared, here we go, equals negative 4 parentheses y plus 3. And there we go. Whew, my goodness. And good news, guys, we got it right. That makes me happy. So, so you actually can see that the value of p is going to be negative 1. So this actually is a downward-facing parabola, vertex at 5, comma, negative 3. And it's regularly shaped. Nope, I lied. It is not one of our classic regularly shaped parabolas, because that would be if a was equal to 1. But don't worry about that right now. We're just worrying about the HK and the P. So, all right, thanks for watching, Internet friends. Bye-bye.